Hello everyone and thanks for joining me for this new video. Today we will discuss CSS grids in page builders, and more specifically we will use bricks because in latest update version 1.6 bricks introduced UI support for CSS grid. And even if you are not a bricks user, maybe you are an Oxygen user, you still may be interested in this video because we will review together the various CSS properties associated with CSS grid. This will be quite a long video, so you will find in the video description timestamps with the different chapters, so feel free to jump to the areas that interest you. You will always be welcome to come back later if you need to. And to start with, let's jump into bricks. And I'm using bricks version 1.6.1 with OxyProps installed, and I'll start by switching to dark mode because this is the way I like to work. And if you are used to OxyProps in dark mode, you notice that now when the editor has a blank canvas, the background is white. That's new in Bricks version 1.6 because now the editor forces a white background on the blank canvas, but you will notice that as soon as I add a section, everything is back to normal and we have our surface one. So now we have a section and a container. So let's start by making our section full height, with a min height of full. So now my section is full screen and I want my container to be centered. So still at my section level, let's add the class supercenter. So this gives me the opportunity to discuss what's under the hood of this supercentered class. Well, if you don't want to use the utility class, or if you don't own yet OxyProps, you can achieve the same result. And this will be our first look at CSS Grid by selecting the section and on the content tab, switching display to grid. The first thing you notice is that the container is now full height because that's the default CSS grid behavior. And if you want the same result as the supercentered utility class, I actually use a place item center property. So it's not available in Bricks UI, but you can reproduce the property place items center with justify items centers and align items center. And now we have our container centered in the section. So that's perfect. You just reproduced OxyProps supercenter class. And if you want to reuse it somewhere else on your website, you can simply delete these styles and create a class c-super-centered. When I create custom classes, I use C as a prefix, so I know that these are custom classes. And now with this class, I can go back with my display grid, justify items centered and align items centered. Perfect. So now let's forget the section and focus on our container. You noticed that when I selected the display grid, a bunch of new fields appeared, and we will have a look at each of them right now. So let's select our container. You can notice that it has the default bricks behavior of a display flex, but I can switch my container to a display grid, and I get back these CSS grid definition fields. For the purpose of the video, you wouldn't do it in real life, but let's give the container a fixed height of 80 viewport height. Okay, so we have a nice area to work with. And now back to my content tab with my display grid. And just for now, before we dive into these elements, let's get rid of this display grid. And before that, in Bricks, you could of course use CSS grids by writing your own custom CSS or using OxyProps grid classes. And for grids, the framework offers different categories of utility classes. The grids, simple grids with even columns, for example, a grid 3 or a grid 4 will have 3 or 4 even columns. We have asymmetrical grids with various width, column width ratios. And then we have the RAM classes. RAM stands for Repeat Auto-fit Minmax, which is the acronym for the CSS function used to create this class, but we will see this a bit later together. So if I create a grid 3 and I had 3 leaves. That's perfect. I have created a grid with 3 even columns. And I can also add a gap between the columns with a class of gap 2, for example. Okay, so now what if I want to reproduce this using the default editor features? Or for example, if I want to use it to create a custom reusable class. So let's get rid of those 2 utility classes. So now we are back with just our 3 divs stacking on top of each other. Make sure we have the container selected, and let's select the display grid. And you notice that our divs stack on top of each other. And this is because with only a display grid, we are telling the browser that we want a grid, but we give no information about what kind of grid we want to create. So the first field we will look at is the grid template columns. And this field for CSS grids will define a pattern for our column width. And to use it, that's very simple. You will use a series of length, and you can use any CSS unit you are used to. You can also use CSS keywords, and you can use a specific unit specific to CSS grids, which is the FR for fractional. So if I want to reproduce my grid 3, what the class does is that it applies a display of grid, but it also applies a grid template columns properties of 1 FR, 1 FR, 1 FR. And now we have a 3 columns grid. This FR unit means how many fractions of the available space should each column use. So whatever the width of our container, my 3 columns will each use 1 fraction. So we have a total of 3 fractions, and each column will use 1/3 of the available width. So if you want to create a grid 4, you just add 1 FR. A grid 5, 1 FR. Okay? And as we don't like that kind of repetitive typing, CSS includes a handy function for grid templates columns. So let's get rid of this. And when we want to create a repeating pattern, because in this case we were repeating 5 times 1 FR, we can use the repeat function, and then we give it the number of repetition, 5, for 5 columns, for example. And then what is repeated, 1 FR. And we are back with our 5 column grid. We can also use it to repeat a different pattern. For example, I want to repeat 2 times 1 FR, 2 FR. And as you may guess, this will result in a 4 column grids with 1 fraction, 2 fractions, 1 fraction, 2 fraction, okay? And for now, we have used FR as a unit, but you are not forced to use FR. You can use other CSS properties. For example, we could have 100 pixels, 1 FR. Those 2 columns will be exactly 100 pixels, and the 2 other ones will share the available space equally because they will all be 1 fraction of the available space. Of course, as we don't like pixels in web design, we could use rem and not 100 because that's a lot. But let's write 10 rems. Perfect. We could also use ch, and this would also work. So you can use any valid CSS unit depending on your needs. And now what if you don't want to memorize this syntax? Well, the good news is that as OxyProps is CSS properties based, when you add something like a grid 3 to your element, let's have a look at our DevTools. Here we have our bricks container with the class. Okay, let's enlarge it with a class of grid 3. And if you are curious and you already had a look at the framework, you know that grid 3 classes, you know that the grid classes use a CSS variable for the grid template columns. So you already have CSS variables available for CSS grids to assign to the grid template column property. Let's make sure my head is not in the middle. So this is the class definition. So to reproduce this grid, you only have to assign the --o-grid-columns-3 CSS variable to the property. Let's close the DevTools, remove this grid. So now we don't have any utility class, but we can select the container, give it a display of grid, and then grab a grid template columns. And this is included since the last OxyProps update, which is 1.4.10, following the new Bricks version. And as for any property fields, you have a convenient context menu panel to get the relevant custom CSS properties. So in this case, I want a grid 3. This applies the correct CSS custom property, and we have our grid 3. So the good news with this Bricks update is that it's now very easy to create your own custom CSS classes, global classes. So let's say that I will create a class C for custom-test grid. And now I can create a custom grid with a grid template column of 3. But I can also give this container other properties like a background color, for example, or anything you would like to add to your specific grid component. Because with this logic, we are not thinking in terms of utility classes, but we will be able to think in terms of reusable component. And we will use inside our reusable component defined by this custom global class grid definition elements from the framework. And that's a good news because you may use your test grid in many places on your website. And if for some reason in a few months you decide that it's not a 3-column grid that you want, but that's a 4-column grid, you just have to come to one instance of your test grid and change the number of columns to 4, and now you get a 4 columns grid. Okay, so this first category, which are called grids, are the most simple ones. It creates a given number of columns with even width, and it is similar to what we can achieve with the grid 1, 2, 3, 4, etc. utility classes. So it's up to you to either use the utility class or use the CSS custom property in your own custom class or at the ID level if you want. You will also notice that in the panel at the end, and that's the case for most of them, you have a custom value. And if you select the custom value, OxyProps automatically fills the field with boilerplate code that you can completely customize to your needs. So if you want to create something specific like I showed earlier, for example, the repeat 3, 1FR, 2FR, you don't have to memorize the correct syntax. You can just call the custom value and you will get this boiler code, and you just have to adjust it to your needs. Okay, so now let's have a look at the second. Let's get back to our test class and have a look at the second category of grids, which is the asymmetrical grids. We already had a preview of this, and they usually are used with only 2 children elements. So we could use a grid 1, 2, for example. And what this does is that it creates a grid with a grid template column of 1 fraction, 2 fractions. So here again, if you don't want to use the utility class, you can just come to the grid template column. Let's get back to our test grid. It's already a display grid. Let's change the grid template column to a grid asymmetrical 1, 2. And we have our column using 1 fraction, 2 fractions. And you can use any combination to fine-tune the relative width of your 2 columns. It can be a 3, 4, for example. It can be a 1, 5. It's up to you. And once again, you can call the custom one and you will get an example code. So these ones are very simple. Before we jump to the RAM grids, which are a bit complex, let's have a look at the sidebars, which can be considered kind of asymmetrical grid, but with some specificities. So up to now, you could use the framework utility class left sidebar, and this creates a grid with the left sidebar and the content div on the right. But this one is a bit more complex than only the asymmetrical grid with fractional units for each size, because the sidebar uses a function. So maybe the best is to go and, of course, have a look. Let's back to our test grid. You can achieve the same result with sidebar left 1. And to be completely similar to the utility class for this one, if you want the elements to stretch, you should add an align items of stretch. And here we just reproduced the left sidebar utility class. And to understand what happens here, let's call the custom code. And once again, you get the boilerplate code. And this is exactly the left sidebar one. So it uses a min-max function. So the structure of it is similar to what we had earlier with 1FR, 1FR. If we had 1FR, 1FR, we would have even width. But here, the first value is this function. This defines the size, the width of the left column, the sidebar. And then the right part, the second column, uses 1FR, which means the remaining available space. And this min-max function defines a minimum and a maximum value for the left element. So what this means is that my left sidebar will be 25% of the container width, and then the right part will use the full remaining width, which will be 75%. But then when the screen size reduces and shrinks, it will reduce until the 25% reach this value, which is the minimum value. And here I use a framework CSS custom property, which is a side header 1, which for information is 20 ch, approximately 20 characters. And so this means that my sidebar will be 25%. But when the screen size reduces, it will never be less than this value, my size header 1, so 20 ch. To demonstrate this, we could have a look at the front end. And in order to see something, let's just give colors to my divs. Okay, so we have the left sidebar, the right content area. Let's enter responsive mode. Okay, and you can see that the left bar reduces until it reaches its minimum width somewhere here. And then it keeps the minimum width. And of course, you can either use the pre-made ones with various sizes, and you will notice that changing from left sidebar 1 to left sidebar 2 seems to not change anything. Actually, it does, but at this screen size, both of them are 25%. But the sidebar 2 uses a minimum width for the sidebar of header 2, when the sidebar 1 uses a header one. So the difference is actually visible on smaller screen. And you can always call the custom one, and then you can change this to anything you want. If you want your minimum size not to be this, but to be, I don't know, something like 15 rem as a minimum, and to be 40%, well, you get a grid with a 40% sidebar with a minimum of 15 rem on smaller screen size. Okay, and you can also choose to have a right sidebar. So this one will be the opposite. And if you want to create a custom one to the right, you simply need to get your 1FR at the end, cut it, and paste it at the beginning of the field. And we have the right sidebar. Okay, so now let's have a look at those RAM classes, and we have RAM fit and RAM fill, and then we have simply RAM. Let's start with RAM fit and RAM fill, and actually we will start with RAM fill. So let's get rid of these two divs, delete them, add new ones. My div will be a card 2. Let's duplicate it back to my container. I want to clear this template. I will remove the stretch align. And once again, we could call the class RAM fill. And let's use RAM fill 2, for example. Let's also use a gap for spacing. And what this does is that it creates a grid, and this grid defines the size, the width of the child element. And when choosing a RAM fill 2, this width is defined as a content size 2 from the framework. And the behavior that we achieve is that the CSS grid will try to fill, that's why it's a fill RAM, the track. And for CSS grid, the track is this row, to fill the row with as many elements as possible to match this content size. So I can duplicate this element, and when I add another one, it automatically creates a new row to add additional elements, because only 5 can fit on this line. And what's interesting with all the RAM grids is that it is somewhat automatically responsive. On smaller screen, you notice that it's changed from 5 to a 4 columns grid, and we didn't have to change anything. And on smaller, it's now 3 columns, and now 2 columns. And there's no breakpoints involved, it's just that this class and the kind of grid template columns it uses will try to fill each row with elements to accommodate an element with a column width of fill 2, which is 25 ch. So let's have a look at what this can be, how this can be done on our custom text grid with our grid template column. So let's make sure we are on the reference breakpoint. We have our display grid. Let's choose a grid template columns of RAM fill 2. And to have the same result, we need to align items stretch. And this will be similar to the class. And let's also add a gap of size 2. Okay. And in the same manner, if we reduce the screen size, we go to 4 columns, 3 columns, 2 columns. So let's have a look at what's inside by calling the custom one. And when you call the boilerplate code, it's an auto-fit, but if we want the same, it's an autofill with a size 2. And the key here is the autofill keyword. This autofill tells the grid algorithm to try to fill each row with elements that have, and I use again the minmax function, a minimum width of size header 2 and a maximum width of 1 fractional unit. So it will fit as many elements as possible to match the given minimum width. And when it's not possible to add one, it will go to the following row. And this 1fr here tells that all elements have the same width and they share the full available width. If I was not using this minmax function, for example, using only the variable, like this, the difference is subtle, but you notice that in this situation, they all have an exact width of size header 2, and there is this small remaining space here that is not used, and that's what the minmax and 1fr is for. It means that this small remaining space here will be shared evenly between all the elements. It's even more visible on smaller screens, like that. Okay, so now what is the difference between the autofill and the auto-fit? And it's not obvious, so let's select the fit to, and immediately you will see absolutely no difference. Aha. Well, that's because the difference is only visible when you have less child elements. So let's remove them one by one. Delete. Okay, still 5 columns. But now let's delete the 5th one. And now we have 4 elements. If I delete another one, now we have 3 elements. So the difference between the RAM fit and the RAM fill, and to make it obvious, let's go back to RAM fill 2. Here we are. With the autofill keyword, the algorithm will try to fill as many elements as possible on the track. But if 5 elements can fit and we have only 3, well, it will just leave empty space. When we use the auto-fit keyword, by using, for example, this template, the algorithm, if not enough elements are available to fill the whole row, will share the available space between the existing element and will increase the width of each of them. Okay, so in the case of autofill, we have this blank space. Well, the algorithm will take this space when choosing auto-fit and share it between the 3 elements. So that's why I receive often questions about the RAM classes and why my elements are stretching even if I specify a RAM 4 and I have only one child element and it is full width. That's because of this auto-fit keyword that will stretch the element to use the full available width if not even child elements are available to fill the row. But once we have enough and we add another one, the algorithm will stick with this 5 columns grid, so the 6th one will not be full width. It uses its own column track. And in the same manner, the auto-fit is automatically responsive to the screen size. Okay, to finish with our grid templates column, let's have a look at what is the under the hood more complex grid class or grid custom property, which is the RAM class or the RAM custom property. So let's get rid of this. We are back to our default. And for now, with our RAM fit and RAM fill class, we had defined a child element width of 1, 2, or 3, or whatever you want if you choose the custom version. But with these ones, you are not defining a number of columns, you are defining a minimum width for the grid elements, and the algorithm will calculate the number of columns based on this minimum width and the available container width. If you want to do the opposite and define a number of columns and let the algorithm calculate the width, you can use the RAM properties or the RAM class. So that's what we get when we use, for example, a RAM 6. What happens here is that the CSS class is fed with your site container width, and as you specify a RAM 6, it calculates the column width by dividing your site width by the number of columns. And from now, it defines that each column will have a minimum width of 1/6, because it's a RAM 6, of your site width. And then when you decrease the screen size, it will be automatically responsive so that each of the columns have a minimum width, still the same one, of 1/6 of your desktop breakpoint site width. Okay, I hope this is clear, but that's it. It takes this width on your larger screen breakpoint, divides it by 6, this defines the minimum width, and the algorithm makes sure that at each breakpoint, this minimum width is still the same, 1/5 of your maximum breakpoint container width. So once again, we can use our test grid and give it a grid template column of RAM 6, and we get the same result. But this time, there is no custom version because this one is really complex. If you really want to know what's behind it, you can always go to your front end and inspect. And I don't want to bore you with this, but here it is. That's our container with a grid template column of RAM 6. And then you can have the full definition of the property. There's a lot of calculation involved to make sure that this works in every situation. Okay, and that's it for the various categories of grids. So what's next? Well, there are other fields. So let's clear what's here. Let's even clear a few of these elements. And still on our custom test grid, let's create a 12 columns grid. Perfect. Let's also create, because here we have defined 12 columns. Let's also define a grid template row. So we have discussed a lot about grid template columns. Well, things are similar for grid template rows. You also have a menu. It's different because things are a little different. But for example, let's create a grid with 8 rows. So here there's a little bug in Bricks. As we are using a custom class, the grid overlay is not visible, but just to demonstrate this, if we were creating the same thing at the ID level, a grid, so just defining the display grid at the ID level displays the grid overlay. So we have a grid with 12 columns and 8 rows. We can toggle the overlay if we want. And let's go back to our test grid. Okay. And something very interesting when you are using CSS Grid and that you want to create complex layouts is that you have, when you define, for example, a grid like this one with a specified number of columns and number of rows, you have a complete control over the placement of each of your elements. So of course, if you let the algorithm decide, it will use the natural flow of your grid and it will fill the lines. And if I duplicate my elements, it fills the line. And then when the line is full, creates another one. You can change the natural flow of the grid. The natural flow is to create columns by filling a row and then back to another row and the first column, etc. This property, grid auto flow, allows you to change this behavior. by default it's set to row. If I change to column, now the algorithm will fill the column first by creating new rows, and at the end will create a new column. Okay, so that's the purpose of this grid autoflow. You can see that there's a third one, which is dense. So let's select it, and maybe the best way to illustrate would be, let's pick up this one and make it visible by a background of brand color. I anticipate on the following, but let's give it a span of something big like 9, span 9. Okay, so it's very big. Now what happens if I duplicate this one? So you can see that the new one has been created, but it's not immediately following the first one because my two small divs are still there. And that's what this grid autoflow of dense does. Let's get back to row. This is the usual behavior. I have a small div, a big one. The following one is too big to fit on the line, so it goes to the next line, and then the last divs in the order of creation are at the end. But if I say that I want a grid autoflow of dense, the algorithm will try to fill the gaps by pulling elements appearing later in the document, but that can fit in the gaps. That's why my fourth and fifth div appear in third and fourth position, and the third div is last. It's because this grid autoflow of dense will try to fill the gaps as much as possible. Okay, let's get rid of them and get rid of this grid autoflow. And just before we go to the following, let me explain what are those grid auto columns and those grid auto rows. And to help with this, I will have to clear my grid template columns of 12. Okay, so now we only have our display grid remaining. And this is used to define default behaviors when no grid template columns or no grid template rows are defined. So for example, I can define my grid auto columns to be 350 pixels, for example. And now the algorithm knows that as no template is defined, well, I have a grid and I use my auto columns of 350 pixels. Same thing happens for the rows. If nothing is defined, I can use 150 pixels or any unit you want. And this defines the default dimensions for my rows. But as soon as I recreate template columns and template rows, I get back my values. Okay, so we can do many things with grid autocolumns and row. We can define patterns, keywords, etc. But let's not dive into this. Just keep in mind that this can be used by the algorithm to define what is called implied columns, so not explicitly defined columns or not explicitly defined rows when they are needed. Okay, so now we are back with our grid. And if you're like me, so of course we have the grid overlay from Bricks, but I like to see when I'm placing items, because now we will discuss precise placement of items on the grid. I like to see my columns. And there is a useful system in the OxyProps framework. So let's add a div to our container, a simple div. It's empty. And this div will be positioned absolutely. So at the container level, we need a position relative. And we also need to create a new stacking content with the class isolate. Okay, nothing changes for now, but it's just prepared for this div. I'll bring it at the top to receive the class O-to 12 grid helper lines. As you can see that as soon as I add this class to my div, it creates those thin lines that are not intended to remain in production, but are here to help you position your elements and know exactly on which column they sit. Okay, so that's a div you can add. You assign this class and you make sure that the container for your 12 column grid has a position relative and an isolation of isolate. And when you are finished designing, you can just delete it. And now we have those 4 divs. And when you select a child element in a grid, you notice that we have those 2 grid items with grid column property and grid row property. And we have a placeholder of auto/auto. So the question may be, what do we do with this? So be reassured, you just have to right click in the field and you will get all the possibilities we have. And actually, many things can be done. The first thing you can do is enter an integer, for example, 3. And this will tell the algorithm for this element on which column it has to start. So that's the first, the start line. Just before we go further, why did I write a start line and not a start column? Well, let's save and have a look at our front end in our DevTools. Okay, we have our grid. And what's convenient with the DevTools is that you have this grid here, this small grid button in the element. When you hover it, you can see the grid, but even better, when you click on it, the DevTools display the structure of the grid. And you can see all these lines, and all these lines have numbers. Vertical ones from 1 to 13 on the horizontal axis, and 1 to 9 on the vertical axis. So it's a 12 column grid, but there are actually 13 lines, okay? And that's important to understand to avoid frustration, because what I just did when entering this integer here, 3, actually I'm not telling the algorithm that I want my item to be placed in column 3. I'm telling the algorithm that I want my item to start for the column on line 3. Line 1, 2, 3. So that's the left side of my element that is placed on the line 3. Okay, that's why that's the start line. The start line for this element is 3. And if I want it to be placed on the 4th column, I want it to start on the 4th line, and I can have a start line of 4. Okay, then the next element can start on 6, and then I create a gap. The same thing is valid for the row. I can enter the start line. You remember, we have 1 at the top, 2, 3. So I can have this element to start on line 3. And here it is, exactly placed with those coordinates. You can consider those values to be the coordinates of the top left corner of your element in your grid. 1, 2, 3, 4, 5, 6 on the x-axis, grid columns. 1, 2, 3 on the y-axis, that's the row value. Okay, so that's the first possibility, a single number. We also have the possibility, let's pick this one, to enter a span. For example, a span 3. And I want, with the keyword span, this element to span over 3 columns. In this case, I'm not defining the start line. The start line will be calculated by the algorithm based on the siblings, but I'm just telling it that I want it to span over 3 columns. And I can do the same for the row with the span 2. And now my element spans 3 columns, 2 rows. Okay, let's have a look at the last element. And now we can have this pattern where we can define a start and end value. So the first one, full, means that I want it to be full width. And full width in CSS Grid is start on line 1 and on line -1. If you are wondering where this -1 is coming from, back in our DevTools, you can see that it's numbered 1 to 13, but if you look at the bottom, this one is also, the vertical one, is also numbered -1. So you can use positive values to count from left to right and negative values to count from right to left. So 1 over -1 means line 1 to line -1. But you can also tell it that you want to start on line 3, 1, 2, 3, and to end on line 6, 4, 5, 6. Or I could tell that I want it to end on line 10. And here it is. I can do the same for the rows. Start on line 6 to line 9, which is the bottom line, as we have 8 rows. You can notice that this way of defining things gives an exact positioning. We precisely define on which lines we want it to start and end, and this defines all the dimensions of the element and its precise placement within our grid. And that's very interesting because this way you can define precise layouts and overlapping elements. For example, let's have this one start on line 2 to 10, okay, and start on row 2 to 9. And let's say that I want it to be my first element, to be at the back. Then the next one, I want it maybe to start on line 3 up to 6, and I want it to start vertically on line 4 to 6, okay, and it's overlapping the previous one. This one is already positioned, but we could maybe enlarge it to 8. And this one could start on 9 and 5 to 8. Okay, so all of them are positioned. And of course, you are certainly wondering about responsiveness, because for now, when I reduce my screen size, everything is squished because we still have the 12 column grid. And well, you could have many ways to solve this problem, but the way I would be to keep my 12 column grids always, but then adjust the behavior of my elements. If I'm working on a very precise layout like this one, for example, at small breakpoint, I want this one to be full width. Maybe I want it to be full height. I want this one to be not full width, but to start on line 2 up to line -2. Okay, remember, we can count backwards from right with the minus, so it's centered. And this one will be 3 to 7, and this one will be 7 to -3, for example. And then your layout is responsive. Okay, the other ways to define those values is a span from and a span to. So in the previous version, we did define the line, the start line, and the end line. Well, now we can define the start line and not the end line, but the number of columns we want the element to span. So for example, if I want this element to start on line 6 and span for 6 columns, this is the way to define it. And this is where I was saying take care of the numbering because of frustration, because if you think I have a 12 column grid, so I will start at 6, so I will start in the middle, well, that's not the case, because the central one, it's not the 6th line, it's the 7th line. So if I want it to be 50% of the width, I need to start on 7 and span for 6. Okay, of course, you can do the same for the rows. And then the last possibilities is this time to define a span, but not the starting line, but the end line. So why would you do that? Well, for example, this one, we just saw that it was a bit complex to know that to be 50% width centered, aligned right we had to start on line 7? Well, we could just say that we want it to span 6, and we could say span 6 and on 13. But if we don't want to remember that the last line is 13, we just want to know that it's the last one, you know that we can always add -1, and -1 will be the last one. And then you have an element spanning over 6 columns, right a line, because ending on -1, which is the last line. And that's it for this overview of CSS grids in Bricks. I hope you enjoy it. I hope you learned a lot of things. It's really interesting to dive into CSS grids because we can achieve very interesting and very complex layouts with it. Let me your comments under the video. Don't forget to smash the like button. Subscribe to the channel if it's not done yet. If you want more information about my plugin OxyProps, visit the website or join us in the Facebook group. I wish you very nice site builds, and I'll see you in the next video.